is the 8th root of 16 over the 6th root of 2. Oh, okay. Well, I know that my answer is going to be in radical form because the question's in radical form. By the way, can't do anything with that. I have 2 different bases, but y'all don't see 16. What do you guys see here? 2 to what power? Yeah. So here's what we're dealing with. And when you have different roots like this, just put it in exponential form. So we have 2 to the 4 over 8. I'm about to make that a half. And then this is over 2 to the 1/6. I'm going to go back and put my answer in radical form, but y'all, the work is a lot easier with fractions. Okay, so this is 2 to the 1/2 minus 1/6. So any questions? I'm just, doing my exponent rules here. I'm subtracting. LCD is a 6. So 3/6 minus 1/6. Look right here. Let me just use my handy dandy. Okay, guys, if you could look at my screen. When you subtract that, are you going to get a positive or a negative answer? It's positive, which means I'm not going to have to worry about rationalizing a denominator. So what does that simplify to? So that simplifies to 2 over 6, which of course is 1/3. So the answer, that's the answer, but I got to go back and put it in radical form because the problem's in radical form. What does that look like in radical form? Cube root of 2. That's what number 11 simplifies to. Number 12. Oh, let me organize my space. All right, so 12 is the 4th root of 4n squared. I don't see a 4. You don't see a 4. Okay, so if I'm taking the 4th root, y'all, I can't take any numbers out because, there's not enough. But from now on, you have to start simplifying radicals. I can't take any numbers out of here, but I can reduce the index. And I can reduce the index because I know my fractional exponent rules. So this is 2 squared raised to a 4th. And this is an n squared raised to a 4th. And remember, it's the same exact thing as this. And it's all about the 2/4. What does 2/4 simplify to? Yeah. So if I give you something like this, notice they're all even. That has an even exponent because you should see this in your pretty little head. This simplifies in radical form to the square root of 2n. So another reason why we use fractional exponents is you guys have to simplify roots that aren't perfect. Even though you can't take anything out of there, you still got to reduce it down. Okay, let's turn the page. All right, so what's funny to me is that the back is supposed to be more complicated problems. These are actually easier. They're easier because if you notice on the back of that page, each problem has the same letter. As long as each problem has the same letter, then it's doable. If they would have different variables, you would have to like move on to the next problem. So on number 9, really the back is like a self-check for you, whether you get it or not. So it's the square root of W times the cube root of W squared. So I know my answer needs to be in radical form, but I'm going to use fractional exponents to get there. So if I rewrite this first piece right here, y'all, that's W to what power? Yes, good job. Times W to what power? 2/3. So go ahead and add those. I think that our LCD is going to be 6. I get 7/6. Do you get 7/6? Ooh, that's an improper. That means there's 7 W's underneath a 6th root. Now remember, you can always, and I really want you to do this. Like, I really hope that you see you've got a whole here and a remainder. Because if you can see that, you don't have to go back and simplify a root. You can just write, oh, there's my whole number, and I got a remainder. That's it. Oh, that's a 6. I don't know if y'all can. Do you have any questions on number 9? Look at number 11. What would you do with number 11? Oh, I'm sorry. Thank you for reminding me. I do need to box that in. All right, so number 11, are you going to be adding fractions on this? I don't think that you are. You're going to be subtracting. Are there any questions on my work up to this point? We're subtracting. I went ahead and found the LCD. The reason why I stopped right here is because at this point, you need to realize if you have to rationalize the denominator or not. Are you going to have to rationalize the denominator? When I subtract, am I going to have to rationalize a denominator? No, good. How come? Yeah. So we get D to the 1/6. It was in root form. Let's put it back in root form. And then number 12. Please do number 12 on your own. Y'all, number 12, you're going to have to rationalize. So make sure you pay attention. Try number 12 without me. You know what? For the sake of time, that's the exit. That's the exit. So face to face, I'm going to call you guys up. KVA, I'll post it. I am assigning a lot of homework, and I want you guys to have time in class to get started. So that's going to be your exit. However, please fill in this bottom part because tomorrow, all of your quiz is for your response. And there you go. How do I know if I'm going to get full credit? By that. An expression is simplified when there are not any negative exponents. An expression is simplified when there are no fraction exponents in the denominator. If there are, you better rationalize. How do I know when an expression is simplified? When it is not a complex. Do y'all know what a complex is? Yeah, you have more than one fraction bar in a problem, basically. Can't have that. Like this. That's a big time no. And now that you know fractional exponents, all of your radicals have to be in simplest form. So this was just an example. We were trying, I can't read that. Maybe your little young eyeballs can. But this is the fourth root of 4. Well, 4 is not a perfect fourth, so I'm not going to be able to take it out. But that can be simplified. That can be simplified because you don't see a 4. You see a 2 squared. Do you guys have any questions? Look, you got to put your homework on a separate sheet of paper because that's how I'm grading it while you're taking your quiz tomorrow. Okay, so what's on the agenda right now? The agenda right now is for you to start doing this and practicing. And also you need to go back and finish that exit ticket. And I'm going to call you up and check. So face to face, you're so lucky because I'm going to call you up and check it. So lucky about that. KVA, I'm going to show you. I'm going to post the answer. Y'all got a lot of problems due tomorrow. I'm giving you about 15 minutes in class. KVA, do you guys have any questions? Because I have to render my video. Oh, hello. Hello, I'm down here. Any questions? If you do not have any questions, you can log out. Have a good day. Bye. Thank you.
Bye.
Bye.